Hey guys, we're going to keep going. Lesson 76. Last lesson for this week. Pretty simple, maybe. Symmetry. We've been talking about symmetry for years, I'm sure. Because things have symmetry. When you start talking about shapes, you start talking about symmetry and how shapes have symmetry. What is a line of symmetry? Today we're going to talk about two different types of symmetry. Okay? We're going to talk about two different types. Okay? This is not one of our transformations, but they do talk about transformations in this lesson. It says symmetry is a property illustrated when the image of a transformation of a figure coincides with its pre-image. There are different kinds of symmetry. A figure has line symmetry, so that's where we're going to start with line symmetry. Probably what we always think of when you think of symmetry. A figure that can be reflected across can be reflected. So we just talked about that just the other day, reflections across a line. So that the image coincides with the pre-image. Coincides with the pre-image. If you remember, we didn't really talk about it when we did reflections, but the pre-image is the one you start with. The image is what you have reflected, okay? The line that divides the figure into two congruent reflected halves is the line of symmetry. So you have a line of symmetry. It's the line that divides. It's the line divides the figure into two congruent halves. Pretty sure I misspelled that. It's a V. It's no F. What am I thinking? Maybe when I wrote it, that wasn't correct. Okay? So, we can have some different things that have a line of symmetry. I'm going to go to the next page so we can look at some shapes. We can look at, we'll do this one. Something I can put up here. Does this arrow have a line of symmetry? Yes, no, maybe. So let's see. If I divide it through, okay, I knew that was probably going to be a bad idea. Now I can't make it go up. Yeah. If I divide it through that end, is the top half exactly congruent to the bottom half? Is it reflected? Is the top half reflected across this line in the middle? Is the big question. It appears that it is. Yes. Meaning if I folded it on that line, the top would be directly on the bottom part. Okay? What about, I know I'm not going to draw this perfectly, a heart. They do a nice one in your book. My heart is definitely not symmetrical, but we're going to pretend it is. Okay? We're going to pretend it is. It has a line of symmetry, meaning if I divided it straight down this line, sometimes if I'm making paper hearts, I take a piece of paper and I fold it and I cut this section. Okay, fold that paper in half and I draw this little side and then cut that paper, and the other side, when I unfold it, is the whole heart. Okay, what I have folded, that's the line of symmetry. Okay, do all shapes have a line of symmetry? No, I'm just going to tell you, they don't all have a line of symmetry. That Nike X or swoosh, is there a line of symmetry? Nope. No line of symmetry. Okay. What about, I'm going to draw a rectangle. Line of symmetry in a rectangle. Could I go this horizontal line? Is that a line of symmetry? Yes. Does it have more than one line of symmetry? What happens if I fold it? Oh, you guys, hamburger style or hot dog style? Both of them are lines of symmetry. If you take that piece of paper, you can fold it hamburger style. Right side, left side, they're on top of each other perfectly. If I fold it hot dog style along this horizontal line, that would be perfectly. Okay. What about we're going to pretend this is an equilateral triangle. Okay. If this is an equilateral triangle, how many lines of symmetry are there and can you draw them? Okay. Well, if I drew straight down through that vertex and I folded it, would the right side look like the left side? Exactly, they would be on top of each other. If this was a perfect regular triangle, meaning a 60-60-90, an equilateral triangle, if I fold it on this line, should the right and the left sides be the same? Yes, they should. Okay. What about this other vertex? Should this right and left sides be the same if I fold it on top? Yes. If we have regular shapes, okay, I'm going to try to draw, let's do a square. Because that's pretty much the one I can draw that's regular, that I know has to be regular. Does it have the same two lines of symmetry that the rectangle do? The horizontal line and the vertical line. Okay, but what about, is there another one for this square? What about diagonal to diagonal? Oh, we're going to pretend that was a straight line. What about the other diagonal? It has 4 lines of symmetry. A regular triangle has 3 lines of symmetry. Okay? What if we drew a star? I've got room for one more on here before we do something else. What if we drew a star? Like this. There we go. If it's nice and perfect, we're going to do a yellow line of symmetry. Do you see a line of symmetry going from that vertex down? If it's perfect, it's going to go from this vertex down. Vertex down. I know I have some more. How many lines of symmetry do we have? 1 for each vertex, or each point of the star. So this one goes through 2, counting the exterior and the interior, the acute and the obtuse points. That's 1. There should be 5 in that star. Okay? That is line symmetry. Let's talk about the second type of symmetry. It's called rotational. Rotational symmetry may be new to you. It's we're going to take a shape and we're going to rotate it. Okay? This is the type of symmetry which describes a figure that can be rotated about a point by an angle less than 360 so that the image coincides with the pre-image. Okay, I'm not going to write all that down. Okay? We're just going to, it's a figure rotated about a point by an angle less than 360. Okay? So that the pre-image and the image will be on top of each other, coincide. Okay? The angle of rotation, that's an important one. Angle of rotational symmetry. Okay? The smallest angle through which a figure can be rotated in order to coincide with itself is an angle of rotational symmetry. The smallest angle a figure can be rotated to coincide with itself. Okay? So, let's look at some different shapes. There's one more definition. We'll talk about the order. Let's go ahead and say it. The order of rotational symmetry. Because we'll talk about all these at the same time in just a second. Okay? Is how many times in that 360 degrees that it will coincide with itself. The number of times a figure with rotational symmetry coincides with itself as it rotates. So, I didn't spell that. With itself within the 360 degrees. Okay? So we'll talk about angle of rotation. What's the angle and what is the order? Okay? So let's look at some different shapes. Here's some these are our definitions. Let's look at I don't want to do that one. Let's start with a rectangle. That's probably the easiest one to do is a rectangle. Now I'm going to take this rectangle. Come on, why are you not working? And I'm going to duplicate it. So we have an original, okay? Here's my original ABCD. Okay? And I'm going to take this new shape, which apparently I changed colors, okay? And I'm going to rotate it. You kind of just, when it squares, I'm thinking 90 degrees. If I rotate this 90 degrees, does my pre-image, the original, match my image that I've changed it to? No, it doesn't. It has to be able to fit directly on top of it, and it doesn't. Okay? It is congruent to it, yes, but it is not fitting directly on top of it. It must coincide everything. Okay? So if I rotated another 90 degrees. So I've rotated how many degrees? 180. Now if I've done it perfectly, which if it was exactly 180, it would fit exactly on top of it. Okay? Is the image and the pre-image, do they coincide? Are they directly on top of each other? Yes. So at 180 degrees, they will fit. Okay? Right on top of each other. If I rotated it another 90 degrees, does it fit right on top? No. What about another 90 degrees? Would it fit directly on top? Yes. Okay, so we would say a rectangle has rotational symmetry with an angle of 90 degrees and order, how many times did it land on top of itself? 2. Okay? It would be a 2 there. Okay? They talk about a square. If we were to have a square, how many times would a square land on top of itself when I rotated it? Okay, this one I'm not going to make an image and pre-image. I'm just going to take it and I'm going to rotate it 90 degrees. Does it look exactly like it did before I rotated it 90 degrees? Yeah. What about 90 more degrees? Yeah. What about 90 more degrees? Yeah. That last 90 degrees, I should be back to my on top for 360. I know it's kind of a little off. So a square has rotational symmetry with a rotational angle of 90 degrees. And how many times did it hit itself? Did it land on top of itself or coincide is their word? 4 times. Okay? So it has a rotational angle. The angle of rotation is 90 degrees, and the order is 4. Okay? Next, let's look at something that might not have. Could something not have rotational symmetry? I'm going back to the arrow. Okay? And I'm going to take it and I'm going to duplicate it just so that we can make sure we know. And I'm going to move it away. Okay, so here's our original. And the arrow that we're going to rotate. If we rotate this 90 degrees, how about 180 degrees? Could I fit it directly on top of it? You want to try? Does it fit directly on top? No, it doesn't. Okay? If I kept rotating it 270, back to 360. Yay! A little hint. Every single thing will have rotational symmetry at 360 degrees. That's why in the definition, it talked about an angle less than 360 degrees. Okay? So, even though this lands on top of itself at 360 degrees, we would say this arrow has no rotational symmetry. Okay, so it's okay if something doesn't have rotational symmetry. Okay, like I said, everything's going to have rotational symmetry at 360 degrees. Okay, there's an example about tiling. Okay, they're regular polygons. Tiles often have many lines of symmetry so they can fit easily into patterns. How many lines of symmetry does each regular polygon have with up to 10 sides? Okay, so it's making you think about regular polygons. We did a triangle and a square. We're going to pretend I can do a regular pentagon, and I may have to stop at that. Okay? Lines of symmetry, if we were doing the lines, we're going to, see, I'm not great at this. It would go through halfway. So the top part should land right on top of the bottom part. If it's regular, it should go through this angle and hit in the middle of that side. And we should have 5 lines of symmetry. Okay? 5 lines of symmetry if it's a regular pentagon. If we wanted to rotate this pentagon, okay, maybe I can just, let's do this. Let's see if I can duplicate just the pentagon. Yes. If it's a regular pentagon and I wanted to rotate it, this is when I can tell it's not a regular pentagon. Okay, when I put the next point at the top, I can tell it didn't line up. Okay, but if it was regular, it would line up. Okay, and it would have rotational symmetry. Every time another point went to the top, it would look exactly like it did at the beginning. Okay, and if we kept rotating it, so it would have 5, an order of 5. Somebody might ask, well, what was the degrees in which you were rotating it? Because we've done 90, and that's really all we've done with squares and rectangles and such. Okay, but with a pentagon, it's going to have 5, an order of 5. Then we would take 360, and we would divide it by 5. And I believe that's 72. Yeah. 72 degrees. So it would have an angle of rotational symmetry of 72 degrees with an order of 5 if it's rotational symmetry. 72 degrees, and an order of 5. If they are regular, that's always going to line up with how many sides does it have. It's going to have that many lines of symmetry and that order of rotational symmetry. Okay? All right. We're done with another one. I hope you guys have had a great week. We're just going to do a few problems from lesson 75. Sorry, this is 76. We did 75 yesterday. We're going to do the practice, which is just 3 or 4 problems, and numbers 2, 5, and 9. Okay? Hope you guys have a great weekend. We'll talk to you later.